Microsoft Defender ATP gathers a huge store of information that can help you detect, investigate, and respond to advanced threats. In this video, I'll demonstrate how to use advanced hunting to query and use all that data. Advanced hunting is a powerful query language that's flexible and rather simple to use, especially considering it uses IntelliSense to autocomplete operators as you build queries to mine the telemetry that Microsoft Defender ATP stores in tables. For example, you can query process creation, network communication, and many other event types. Detailed schemas are available for all of them. Some results, like machine and file names, link directly to detail pages in the portal, helping you pivot easily between the advanced hunting and portal investigation experiences. Big time saver. And last, the welcome page provides basic and advanced examples to get you started with the tables and query language. In Microsoft Defender Security Center, on the Advanced Hunting page, the sidebar shows the schema you use to build queries. There's one list for each table, like machines or alerts, and each list contains the table's columns. For example, columns in the File Creation Events table include the file name, folder path, hash, and many other data points. Likewise, the Machine Info table contains columns for the operating system, IP address, and so on. I'll use these tables later to build an advanced query. You won't find a description of these columns in the schema, but take a look at the Advanced Hunting column reference. It provides detailed information about each, including its data type and description. Before showing you how to build advanced queries using this schema, we recommend getting to know the basic examples. That's next. The Get Started section contains examples that show how to query Microsoft Defender ATP telemetry. There are two sets, Basic and Advanced. I'll start with the basics. Under Project, select Run Query to run the example. This is a simple query language that has elements of PowerShell, like the pipe character. It uses the where operator to select rows from the File Creation Events table created in the last hour. The limit operator restricts the results to 1000, and the project operator selects specific columns, like the file name and event time. Below the query are the results. To view details about an entity in them, like machine details, select the hyperlink to open them in a new tab. With this basic example under your belt, building a custom query that extends it is a great learning opportunity. Next. Ultimately, I want to build a query similar to the basic example, but I want information about machines that are defined as high-value assets, along with the number of failed logins. So I'll start with the Machine Info table and filter the results to show machines that are tagged as a high-value asset. To select the columns I want to show, add the Project operator, followed by a comma-separated list of columns. Last, use a join operator to merge the Machine Info and the Logon Events tables to include logon events in the query. This way, you can hunt through a smaller number of failed logon attempts for the most valuable assets in the org. That's it. Run the query and you see the results. Results are clickable and bring you right to this specific event on the machine timeline. Next, I'll show the advanced filter capabilities you can use to refine the results further. After running a query, you can filter its output. Each column in the results has a section in the filter, and within each, you see a list of unique values for that column sorted by prevalence. Refine the query by clicking the plus or minus signs next to a value to include or exclude it. As a result, the filter adds a where operator to the query statement. Run the query again to update the results. Another nice ability is custom detection, based on my own queries. I'll describe how to do that in the next segment. Custom detection rules are queries that run as a scheduled task. When the query has results, it surfaces an alert, just like any other alert. They do require the event time, machine ID, and report ID columns in the query. I'm missing the event time and report ID columns, so I'll slip those in there. Once the query is ready, creating the detection rule is simple. It needs a name, metadata like the severity and category, and a description. Select Create to save the rule. After the query runs, here's what the custom alert looks like in the Security Operations dashboard and the Incidents dashboard.